Okay, we're coming down probably the simplest part of all, and what I did is I went ahead and went through my collection and I picked all pretty close to the same length, because I'm not going to bother finishing these off for 50,000s, 100,000s, or whatever it is on the length there. I'm going to leave them just a little bit long. I will still dress them with the sander and still give them a radius like in the drawing. But right now I'm just putting a 1/4 inch hole right in the center of these. And then after that, I'll put the chamfer tool in here and we'll just break that edge on both sides. Alright, we're just breaking the edge now. We went ahead and we backed it out because when we flip it around, or we had these things in and out, if I had it this way or whatever, I'm still going to center. And I just leave the jaws just slightly loose because it doesn't take any pressure, but yet it lets you get right in there and get the job done. You know, it's going underneath the bolt, but it's not, you don't get to see it, but at least when you put your kits together, take them apart and change out the bearings later on, you get to look in there and see that chamfer. It just won't interfere with anything. Your bolt, if it has a radius up by the head of the bolt, you know, you'll be seating in on the flat of the bolt, the head of the bolt, where you need to. And that's the last one. Okay, I took one of my, actually this is one of the V blocks that we were holding the center sections together, and in welding up the tube assembly. I took a piece of 5/8 stainless. It was almost about the length I needed, so I just finished facing it off at 2 inches so I could set it there in the mill here. Now what we're actually doing here is we're gonna machine these to length, and I'm gonna go get one of the box tubes there to actually take a measurement in there. I believe it's 3/4 of an inch. It's a 1 inch box tube, 1/8 inch wall, or 11 gauge, so that dimension should be pretty close to 3/4 of an inch. We will see if maybe it might be a couple thousandths either way, 5 thousandths either way, or whatever, and we can compensate and make these all to suit. And that's another reason why I left that dimension as a mistake on the drawing. It's just plus material. What that dimension actually was the dimension that I was cutting the material to. And that's how that ended up being on there. And so we sold our small south bend lathe, which I would have put these in there and faced them off, and that's how normally I would have done it, because then I could go ahead and face it and then break the edge inside and outside, and that's how I would have these little cylinders machined off. But I don't have that luxury right now, and I can't put these in my big clothing, so I'm going to go ahead and set up in the mill here. And of course I can get the dividing head and then I could hold it, but there's not really enough room to slide in a parallel and everything else. So I always wondered how holding things in the V blocks right in the mill work out. And so by putting this in the V block, which is square with the table, and so everything it's holding that tube perfectly square. So I've got it clamped down there. Okay, let me go get one of the rollers bodies so we can measure our actual length, and then I'll come back here and we'll get started on this. Okay, we went ahead we brought two out here just to show you that we have a little discrepancy between tubes, and nothing really. I'm trying to get, see, I ground in here, so I'm reaching over inside here where we got a little virgin material to work on. So we got about 770 on this one, and the outside measures 1 inch 10, 12. So it's like it's spread out just a little bit. Alright, this one here measures 755, and it's like 1 inch 5 thousandths. The ones that are all that I left in there, because I went ahead and measured the other 4 that I have in there, they fall in between these two extremes. Okay, so basically if we get these things, I'm gonna go ahead and I'll machine one, and we'll get it down to like 760 or so. Yeah, you know, the fat ones, of course we'd draw it in and it'll bring that sidewall in there, and it's not going to hurt it because it's spread in the middle, but it's the box tube out here at the outside edges is comparable to the other box tube that wasn't spread. So machining stress relieves in a lot of different ways, and that's where we get some of this difference in there. But you can actually machine it down to probably the 755, 760, somewhere in there, and it would probably fly just fine from there. And that's kind of what we're going to be playing with right here. What are we going to use? And so we're going to do a couple links, and we're going to test fit them in there. What we end up might be is just going right to about 760, 755, somewhere in there. And because it is nice to be able to reach right down in there instead of fighting that thing to get in there. Okay. All right, let's zoom you in on this. So because we're gonna eyeball the alignment on this and then get this set up. We have a this is a Japanese 4-fluter non-center cutting, but it is sharp and it's fairly new, meaning not used as much. This is a Kobel company from Japan, high-speed steel. Okay, brought you in at least this close here just so we could see how we do the alignment, and when we change out for the cutter we'll have to change the camera again because we're going to be bringing the table up. Alright, this is just a 1/4 inch center drill extension that I broke off the center drills a long time ago, and I just keep around, and I kind of ground this one in here flat. This tube here happened to be somewhat deburred on the end, so I can actually see it. This is a 1/4 inch, and a little bit larger than 1/4 inch on the inside of this pipe here. So I see equal gap all the way around it. Okay, I'm going to consider that 0. Alright, now we can go ahead and lock down our table, and we're going to go ahead and change out to our end mill here. Okay, we're changed out with the end mill, and we're ready to come down. Now our first operation is going to be just to one side, and what we want to do is we want to get a good flat surface to where we can flip it over and have a good flat surface that we're going to mate the next surface to, and so we don't really have to remove a whole bunch of material. So this is kind of the test side where we get to test how the material cuts and so on. Most of these are, that's like 880, there's 850, 885. You know, these are all cut off with a cutoff saw, so I mean they are random lengths there. Alright, and I didn't measure the one before I put it in there. I'm just going to go ahead and fire this off. And what I like to do, my auto feed is not engaged as far as the gearbox going, but by engaging it and using the hand wheel, you can come down and you can baby, and also you can make sure that things don't grab on you. I mean, you don't usually do a face cut and don't have a grab, usually like a drill bit or something. But anyway, I've dabbed a little oil on there. Let me bring you on in. Kind of smooth, I like that. Alright, looks like I kind of got that whole face. That looks all clean and everything else. You see that? That's just a little tiny bit of rollover on the inside. The outside doesn't have too much. I'll be able to dress that up. I can just hold this up against a countersink and spin that. And this outside right here, I can just lightly hit that on the Wilton sander by hand and be ready to fly. Okay, let's pull this out, and I'm going to hit the one side on all of these. And just for curiosity, what is our length on this one here? Alright, that was 8/10. I didn't set a 0 on that one. I should have done that. Alright, we'll do that on this one here. Oh, they're all different lengths. We're just going to kiss them off right now. Alright, we'll pick the shortest one to start the second side. I'm working pretty sweet for not having a lathe. Okay, I'm going to try something a little different instead of pulling that whole thing apart there. There we go. Make the change out a little faster. Almost faster than chucking and unchucking a 3-jaw there. Okay, I can see a little bit more on that inside. I don't know if that's want to see how thick that. Okay, it pops right out. Okay, I'm not worried about it then. This is cutting pretty clean. So this end mill is getting the job done. All right. And I'm just looking in there until I see that the chamfer, the sanded ring around there, same thing there. That's just really light, paper thin, almost like flashing, but it's just rollover. All right, 2 more. Yeah, this is taking a long time, huh? Pretty good grind on there. I'm getting a cut off of every one of the the flutes. Would that be something brand new end mill and you're not getting a cut off of all of them on the face? All right, we're gonna flip it on over. Okay, we've got it flipped over, and we're gonna touch off and then take a measurement. Right now, this is like 800, somewhere in that ballpark. It's the shortest one we have. All right, roughly took about 20 thousandths from when I touched there. We'll set 0. Alright, and pretty close. Okay, that's 70, 80. So we got 30 more to go from that spot. That is cutting nice. Alright. Be easy cleanup. Alright, holding that in there nice. Okay. Alright, so we'll bring it on down and we'll take the other 30 out of there. Okay, that's our 0. Add a little bit of oil here. Oh yeah, we did say that we were about 755. Let's go 25 here. And then we're gonna try this one in the tightest one we had, the body. Okay, we'll set that off at the end. Blow this off. Okay, let me bring you out so you'll see something. Okay, our width here, 755. It's kind of what I think this is the one that measured shorter or smaller. Yeah. Okay, fits in there real nice. Meow. How you doing, Shanann? Meow. Okay, I like that. And I think the other ones that are a little wider, of course they're going to go in easy. But then when we tighten them up, it should draw it down to where they're matching the width. And then this will become the same width as this is out here. Alright, I'm happy with that dimension there. So I'm going to go ahead and bring it back down to that dimension and call that 0 and machine all the other ones to that. I'm not going to overcomplicate and have different sizes. So for all the assemblies that I'm putting together, this length right here will work on them. That one was almost 50 thousandths taller than the other one. And we said 25. We're going to reset our 0 there so we can match all the same to that height right there. And that actually comes out of 750 there, so might have had a chip or something. We'll blow this out here. Alright. Alright, we got our little spacers here, and we have a small countersink set up here in our drill press, and we're going to go ahead and break that inside there. Alright, I like to take my channel locks a lot. This happens to fit right in the bottom there, so I can just quickly hold it and break it. Okay, the bearing shafts, they're only 1 inch long, but actually they're 1 inch 20. The reason why I like them 1 inch 20 is I like a little bit of positive holding with that little flat bar on the outside. I've made one right here, and we're about 1 inch 22, somewhere around in there. That's ideal. My very first one I turned was actually right about 1 inch right on the money. I fit it in there, and I'm not going to be happy. I don't want them to be loose. I want them to be a little bit under tension with those 2 straps that support or hold these in. Alright. So what I do is I take this has got a raised burr on the backside here, and this has got the part off tool, little noogie on the end of it here. Now inside my jaws, there's little grooves. The third one in, I kind of like put the end of that right in there so I can spin it, and then I just push it against the back of that little groove, and that's my stop. Then I come in here and I knock off the little noogie on the end here, and then I touch off here, and we got about 100 thousandths. All of these are about 1/8 of an inch long in this batch that I'm doing, so I just take 50. And I just space that off there. And that's 30 right there. All right, we're gonna go ahead and we're gonna kiss that right there. All right, now we're gonna go ahead and turn this around, but we're gonna measure it before we put it back in. All right, that's 1 inch 27. So I was trying to just leave enough to where I know that I can go ahead and just turn it, skim it clean. Now I don't register the backside because it doesn't have a raised area. I just kind of eyeball it into there. And then this is just a touch thing. I'm going to go ahead and just lightly touch it and then face it off. Break the edge. And that's all we need to do. Okay, 1 inch 25. All right, so it's within the tolerances I want to go ahead and make them. All right, so here we go again. We open it up, we put that in there, we rotate it till it comes to the back side of that slot and stops. Knock off the noogie. Come on out here, touch. A little bit less than 100. All right, come in here, take another last 30 here. One inch 23, same thing. Stick it back in here. One is 22. All right, we'll finish turning the rest of these here. This is the last part of the job we got, and then we'll be looking at a paint job. All right, we'll see you in there. All right, we come out here tonight. It's been 2 days since we painted them. Here's a couple pictures of us painting. We spray bombed them outside with the Krylon True Blue is the color. That's the original color. I was using them today, so they're in the other room there. I had them in here talking about my old set and the new set, how they haven't changed. Same original design 20 years later. It has proven itself. I've had some serious weight on. 6-inch shafts around 12 foot long. I've had 4 or 5 inch long shafts in between the 14 and 16 foot range from time to time. On my rollers over that period of time. I made a larger set a version of 3" by 1.5" and a little bit longer, and they took a little bit bigger roller, and you could put on up to an 8" shaft on it and roll it real comfortable. You can, you know, as long as you have a forklift or something like that, set your shaft gingerly onto your rollers without crashing them. They will handle a lot of weight and roll it with precision. Anyhow, I'm in here and I wanted to finish up this roller assembly video with me actually putting the rollers together, and I have 3 left here to put together. And so I have the shafts here. What I did before I even start coming in here, I make sure the shaft passes through the bearing. The bearing is a closer tolerance than the reamed hole I put in the box tube. My center tubes are all faced off the length, and of course the keepers are here, and I got the bolts there. And what I do, and I mean, I'm real happy. Every one of these things flip over like butter, and even after painting, they are still spinning. I haven't put a drop of oil in them yet. I just wanted to let the paint job have a little bit of chance to harden up and stuff like that. But the first thing I do, because the pin, the hole's been reamed, and then it's been painted, and that's the, you know, just like when you have something powder coated and that mill thickness runs over onto your machine surface that you actually want. You machined it to be a tight fit for here, or a reasonable slip fit, and then you put paint in there, and so you have the interference. So what I do is I just take my reamer, and then I happen to have a chuck, just so I'm don't get in the habit of putting vice grips or something like that on the end of it. I'll have to smack you. All right, so we take the reamer, and all we're doing is taking the paint off. So we run it through, straight on through like that, both sides. Okay, now I can put that here. I'm going to need it again. All right. Then I go ahead, and after I made sure that my rollers fit through there, then I take my roller and I stick my finger in through that side there to hold that, and I gingerly push it on through like that. They go pretty painlessly if you do this process. If you don't, you skip somewhere in between there, and you're fighting your pin through your bearing and or through your housing, then you probably won't be a happy camper in 10-15 minutes after starting your job. All right, if I'm right close to it, I take the wooden part of my hammer and tempt it in there. All right, once you have the 2 bearings in there, I take my screw here, bolt 1/4 inch 20 by the length it is, and get my nut ready on that side. I hold this roller sideways here, and I put the spacer right in here, and it is nicer when the tube is slightly spread versus being crimped down or tight on your Alright, might want to have one of those handy just in case you have a stubborn paint job there. Alright, so once that goes down through there, and that flat bar, you want to hold it parallel, unless you want it cocked for some reason, but I kind of like it to look straight. I don't know if I'm the only one that does this, but I always look for the stamping or whatever on the nuts, and I want that to go on the outside. I don't know, I've always done that. Just like you can see the grade 8 stamp on this side here. So anyhow, grab your wrench here, and I'm trying not to put it down against the paint job. There we go. You can reach in there. If you're spinning it slightly, then you don't have enough squeeze tension on it, because it is supposed to bring it in against it. There we go. The tube and the bolt inside create the ultimate strength that you're going to get out of your set of rollers. Because you've opened up the web. The vertical web is your strength. And when it's a complete box, the top is being held from spreading and the bottom's being held from spreading. And when you have it milled out open like this, you're allowing a flimsy vertical in that center section. By putting the bolt and the spacer in there, you regain the rigidity of it for at least the height of that center section there. You do have the pins and you have a lot of other things there that are probably going to add a little bit on it, but you're only as strong as your narrowest section, and if that section stays straight in line. If it goes in or out, you've lost it. So the strut support is what that is, and that's why you're able to load the weight on these rollers for their size. All right, I'm going to go ahead and get on to the next one here. All right, okay, we got one left to do. We also come out and we assembled our new bait. Of course, they're not tight yet because I'm getting ready to box them up and ship them. But I have a new steel plate with 3 aluminum round-headed rivets to go through, and then I just peened the top here, drilled and tapped this for a regular indicator rod, and eliminated the mag base. You know, I use a lot of water cooling down and things like that while I'm straightening and shafting, and so over a period of time some things do get rusted up if you're not using them, and mag bases are one of those things that if they continually get wet and you know, they start to fail. Anyway, we're just about ready to box these things up and take them to Cucamonga with us for Stan's 2016 Summer Bash, and we're really excited. And of course, I get a brand new pair here at the shop, and I'm glad I got a chance finally to go through and show you how I put them together at the beginning. I just had the picture in my head, and that's where it's been for 20-something years, and bring it to drawing, and actually I've had a couple other volunteers that come in and did some really nice drawings, and you know, the little mistake on the dimension, and also leaving out how I joined these upright supports to the base. Let people use their own ideas. There's been a lot of videos that have been sent in to me via email, tagged on Facebook, and also some guys putting together other videos. And so any of those videos, any of those places that you can see somebody doing something different with the rollers by you know, not everybody welds, you know, so somebody wants to set up and do a machine cap screw, countersunk cap screws or whatever coming in from the bottom, and locating them. As long as you're locating that precision surface to the flatness, and you're keeping these things vertical, and you've got the freedom in your swivel or the trunnion. The trunnion is the most important part of the whole roller, and that's why you can they work anyway. You can check straightness on just about anything that's round on any surface. All right, so till next time, get it done.